act is to do some hand waving, if you will, or talk a little bit about normalization and normal forms. You know, a lot of times they put this early in a book, and it's not a bad thing in a database book, but boy, until you built some databases and then have to design one, does some of this notion of normalization come into play. And this Wikipedia is a pretty good article about it. If you remember way back in MINF 3650, those that had it, I kind of introduced the idea of normal forms from a simple requirement of a teacher, maybe a middle school, trying to keep track of accelerated reader results. Accelerated reader is a program, a child picks a book, right? Presumably they go read it. They come back and get tested on it, and depending on how well they do on the test and how complicated the book is, they earn some points. So harder books are kind of like harder dives in the Olympics. They kind of count more a little bit, but maybe if you can execute perfectly a mid-level dive, you might score better than doing a so-so job of even a more complicated dive and things like that. My middle daughter, I always like to joke, she came home and they talked about accelerated reader at school, and when you got so many points, they were going to go to Adventure Landing, and this is great. And bright enough and cheery enough kid, maybe not the sharpest knife in the drawer, and it was only like in the 6th or 7th grade, and said, we went to the library, we got a book, and I said, oh great, well what book did you get? And she said, Crime and Punishment. And I said, Crime and Punishment. Yeah, it's originally in Russian, this story about a pawnbroker who gets murdered and the racking of guilt of the person who did the murdering, and they start taking over the person's diary, just this dreary thing. I couldn't even finish it. April, what did you go get? Crime and Punishment. Well, she's smart. She said it had the most points, right? If I get it good, then I'm going to have more points for me. So she kind of worked that way. Ended up somewhere else in doing. So here's kind of what I'd want to maybe try to get to. This is the way that an instructor, a human, a real person might think about their data. Okay? And we can maybe envision it being done in a spreadsheet, right? Excel, and it all makes sense. We know who the students are. We know what grade they're in. Oh, by the way, there's a factor. So a third grader doing the same on a test as a second grader only gets 85%. A first grader gets 100%. So so it's kind of, there's something with that, the grade level that goes on. We know what books they've read. We know how many points the books are worth. We know what their test points were, and this points earned is if you take this times that percentage, then you get the points they've earned. All makes sense, no real questions, and for 4 people we have no problems. Well, when you read, or if you read this article in Wikipedia, the problem with storing the data this way, think about storing in a spreadsheet. We kind of give a name, leave 2 blanks, give another name, leave a blank. We sort of understand that these go together because of the 2 things that are underneath belong here, but that's bad, right? If we sort this, we're going to kind of lose that context. So if nothing else, it's probably better to have Tim Smith 3 times here, third 3 times. But there's also what they call anomalies, right? What if Tara leaves? This is a deletion. An anomaly is a weird thing, a bad thing to happen to the data. What if Tara were to leave the school? Okay, they say no problem, just take Tara's records out of there. Well, the problem is this line of Tara's isn't just about Tara. This is where we have information like a second grader gets 90% of the credit. If we delete Tara, we also take with that second graders are worth 90%. We also, I think, lose the fact that Paradise Lost is worth 1,000 points. Okay? And so while it's no problem to remove, and I've been saying Tara, but I mean Tammy, right, on all this. Second grader, Paradise Lost is 1,000. The problem with this representation from a data storage is we have 3 or 4 different things we're trying to store, but we're doing it in one list. We have students, names and what grade they're in. That's one kind of fact. We have books and how many points they're worth. That's another kind of fact, right? We have grades and what their percentage is. That's another kind of fact. And then we have kind of the combination of a student and a book and the score they got. That's a fourth kind of fact. And having those all mushed into one representation makes it hard to update, to delete, to manage. You know, what do we do when a new book comes in that nobody's read yet? Okay, do we add it down here with nobody next to it? It just turns out to be unwieldy. I don't know if I remember to put a link to the coup de grace here, but let me jump to it and then talk why it is the right one. And then I meant to make a link to this, and then I got busy here. This is the underbelly of my web page. That's the one we just looked at. This is taking that information and creating the appropriate third normal form design for it. So the way you would actually build the tables to store that data, I kind of outlined we really had four different themes, four different kinds of facts we were trying to keep, and the normalization process, 3 stages of 1, 2, and 3, take you from that great representation for understanding to a form that's more appropriate for storage. And so you would end up with, we have one set of facts we want to keep track of, and that's called students, right? Now we had to add some things like something to make it a primary key, but the student belongs to a grade, and if you're in third normal form, then every non-key attribute depends entirely on the key. So we need to know who it is to know their name and what grade they're in. But we don't need to know who it is to know anything about books. We don't need to necessarily know who it is to know what the grade factors are. Right? So one set of facts we have is what are the students? Another set of facts are what are the books available? And now think about what happens if Tammy leaves. Well, when we get rid of that record, all we lose is Tammy. Maybe we need to take out some of her tests to go, but we don't lose the fact about the second grade, and we don't lose the fact that Paradise Lost is also worth 1,000 points. When we want to add a book, oh, here's a book that's available. We have Beginning SQL Server 2012, right? 10,000 points, right? We can just add the book here, and just because nobody's tested on it, no problem. It makes sense. It's one of the available books. We get a new student in. It's one of the students that haven't taken any tests. We haven't linked things together that depend one on the other. So that's kind of the end result. I want to go back to where we started. And so in the factors is the fourth fact. And this one is kind of a fact that does depend on 2 things. To know the test points, we need to know who took the test and what book they tested on. Now, in this particular system, 1 score per test. In D2L, I can give you 2 and 3 and 5 and however many tries I want at a quiz, and it remembers all those grades, and I can say take the average, take the best, take the worst, or something. Here, given this model, a student can test on a book exactly 1 time, or we can remember just 1 score. But this has a composite key, because it's really, there is a many-to-many relationship via tests between students and books, right? 1 student could read many books, 1 book could be read by many students, and so there's a junction table. Notice we also don't need to keep explicitly points earned. It's almost like a virtual column. We can calculate that on the fly from the values that we have at hand, and so what a database management system allows you to do then is store the data this way, and then write queries, codes, and that kind of thing to present it any way that's desired. And it all has to do with the, and I'll just kind of call it the idea. Then we'll look at a few examples, because the Wikipedia article does it, that every non-key column depends on the key, the whole key, and nothing but the key, right? So a book's title and book points depends entirely on the book. The test points, I need to depend on the key. I need both the student, I need the whole key there. I could get test points just by knowing the students. Yeah, that's the problem if I had like, why not have third and put the 85% and second and 90%? Factor doesn't depend on the student. Factor depends on grade, grade depends on student, and so that functional two, we separate that into a separate table. So if you can kind of look at that and say, yes, I can see how I would do crud to that to represent any situation. And think about the new student coming in, a student leaving, a new book coming in, a book leaving, a new grade, a change to a factor, a new test is taken, and you can envision what happens. But if you read about normal forms and kind of get in there, there's some good examples, or at least some, and I recommend it for your inspection, but let's see. Thought it was good examples when I did. Right, first. Okay, so first, this is a bad thing. Whenever you have, one of the requirements for a relation is that the values in each cell, if you will, be atomic. That is, here, what do we need? A home phone number and a cell number. Here we're calling telephone number two things. So something that's in first normal form would say, no, don't store that with a set of things. And that's how first normal form is defined. As long as all the cells are atomic in their domain means whatever type it is, string, whatever, then we are. So first normal form would look like this. We have two records for Jane Wright to represent, we have two different phone numbers for Jane Wright. And we want to actually add a column here that says home phone, cell phone, maybe to distinguish what type of numbers they are. But that gets this guy into first normal form. Not first normal, in first normal. Okay. Second normal, and kind of first through 1 through 3 are the ones that everybody really worries about. There are so you can get into examples. Okay. Right. So here's this is a fine relation, and it's in first normal form. The issue is we have Forte as a manufacturer that is Italy, and Hope is in Germany, and so we have things that don't depend entirely on the key, and so where a manufacturer is gets into one table, and everything about the model and who the manufacturer is gets in another table. So we had what's called a lack of a functional dependency. This didn't depend on everything here. It depended on the manufacturer, but it didn't depend on the model, right? So since this doesn't depend on the model, then it gets its own table. So, and I'll only look then at the third, because some of them I can see them. And so, there's nothing but the key. And here we have a transitive dependency. It's called a functional dependency that's in non-key columns, right? I don't need to know the tournament and year to get the winner birthday. The winner is something that goes along with the tournament and year. The birth date is something that goes along with the winner, right? So if Al Fredrickson wins 2 tournaments, the better way to store this, the 3NF, third normal form, way to store this is you have a table of winners with the facts that go along with the winners, and then the tournament year and who won. Okay? And so just wrapping your minds around it, and I think at this point we can leave it at that.